Okay, so for question 3, part B, we're trying to figure out the annealing temperature, which is the ideal temperature to perform during the PCR reaction in order to let the primers that we have made match up and form those hydrogen bonds with the template strand. So up here is the basic formula, and I'm going to be honest, I do not remember why these constants are what they are. So the 81.5, the 0.41, and the 675, they're very specific numbers that you use each time, and they are there for a reason, but I don't remember why those numbers are what they are. The important ones that you're going to be filling in are the percentage of GCs in the primer, and then the overall number of bases that are in the primer. So for our first primer, there are 16 bases in it. So we're going to put our first constant here, the 81.5, our next constant of the 0.41, and then you want to put in the percentage of the G's and C's that are in those total number of 16 bases of the primer that we made. So counting through, there were 9 of them total, and so we take 9 divided by 16, and instead of putting it in a decimal form, for this equation you actually put it in as a percentage. So we put in 56. And then subtract with the constant that we have of 675, and to fill in for n, that's the total number of bases that are in our primer, 16. So when we plug that all into the calculator, we get the 62%. So we do the same thing for primer 2, put our constant of 81.5, plug in the other constant of 0.41, and that primer is also 16 bases long, but when we count through on that one, there are only 8 of the 16 that are G's and C's, so that was 50%. Then we subtract the 675 and the total number of bases again, which is 16, and we get our final percentage of 59.8 degrees. And those are the ideal temperatures in order to let those primers anneal to the complementary strand and amplify the region that we want.